In this exercise, we're going to look at finding all the factors of a polynomial. In this case, we have a degree 3 polynomial, and we're going to use synthetic division to find all the factors. And what we've written out is a synthetic division table, if you will, and we're going to use the factors of R, the numbers of R, to find out if there's a remainder. So we're going to use synthetic division to see if there's a remainder. Of course, if there is a remainder, that means that number is a factor. Of course, remember you have to change the sign, so we'll see how that works out. So using synthetic division, we're going to take bring the first number down in all cases. So you'll write down the 1 all the way down the chart. The next thing is to multiply the 1 by the -4, and then take that number, -4, and add it to the number at top, which is 0. So 1 times -4 is -4, plus 0 would be -4. Continuing the process, -4 times -4 would be 16. 16 minus the 7 at the top would be 9. 9 times -4 would be 36. Excuse me, -36. -36 plus 6 would be 30. So we see that -4 is not a factor. Continuing the process, 1 times -3 is -3 times 0, or plus 0, excuse me, is -3. -3 times -3 is 9. 9 minus 7 is 2. 2 times -3 is -6. 6 plus the 6 at the top would be 0. So we've identified that -3 is a factor. 1 times -2 is -2. Remember, all of these in the second column, because there's a 0 at top, all of them are going to be the same. So 1 times -2 is -2. Then you don't do anything to it, you add 0. So you get -2. -2 times -2 would be 4, and 4 minus the 7 at the top would be -3. -2 and -3 multiplied would be 6. 6 plus the 6 at the top would be 12. So -2 is not a factor. -1 times 1 would be -1, and then 0, of course. So it would be -1. -1 times -1 would be 1, plus the -7 would be -6. -1 times -6 would be +6, plus the 6. Therefore, you get a 12. So -1 is not a factor. Let's continue on. 0 times 1 is 0, plus the 0, 0. 0 times 0 is 0, minus 7, minus 7. 0 times -7 plus 6 would be 6. So that would be not a factor. 1 times 1 is 1. We'll put that here, plus the 0. Remember, you don't change it. 1 times 1 is 1, minus 7 is -6. 1 times -6 is -6, plus the 6 at the top. That would be 0. So 1 is a factor. And then 2 times 1 would be 2. 2 plus 0 is 2. 2 times 2 is 4. 4 minus 7 is -3. 2 times -3 is -6, plus the 6 at the top. So we get 0. So 2 is as well. So we've found the 3 factors of x cubed minus 7x plus 6. Remember, there are only 3 factors because this is a 3rd degree polynomial, and that gives us 3 possible roots. So now we can explore the other method by using the factor theorem and just testing some values. But we already know in this case that -3, 1, and 2 are indeed factors of the polynomial. So we will take one of these and plug it in. Let's see how the factor theorem works. If you don't know going in, then you would just have to test some numbers just like we did with synthetic division. So let's pick one of the factors that we found previously. And in this case, let's do 1. So what we're going to do is find f of 1. We're going to plug that into our function and see if we get a 0. So f of 1 is equal to 1 cubed minus 7 times 1 plus 6. So 1 cubed is 1, minus 7 times 1 is -7, plus 6. So that indeed is equal to 0. So what does that mean? That means x minus 1, not x plus 1. Make sure you get the sign correct. X minus 1 is a factor. Now we have to use synthetic division to be able to find out what the depressed polynomial or the quotient is, and it's going to be a second degree. We've already done that in the previous example, and I'm going to highlight it in pink. The quotient or the depressed polynomial is 1, 1, negative 6. So we can use that to write the quotient. So here's the quotient, x squared plus x minus 6. Now we have a quadratic, and we can factor that because this factors into x minus 3, x plus 2. So all of the factors of the polynomial, using both methods combined, x minus 3, x plus 2, and x minus 1. If you had a higher degree than 3, then you would just have to simply keep doing the process of synthetic division or using the factor theorem to find those factors, using those depressed polynomials to get down to when you can get to a quadratic. You get to a quadratic, hopefully you can factor.